In this lesson, we will look at slant asymptotes for rational functions. The definition: the line y equals mx plus b, where m is not equal to 0, is called a slant or oblique asymptote of the graph of a function y equals f of x if as x approaches negative infinity or as x approaches positive infinity, f of x approaches mx plus b. Here we have the graph of a function y equals f of x having the slant asymptote. We'll call it y equals mx plus b. As x approaches negative infinity, f of x is approaching this slant asymptote y, and as x approaches positive infinity, f of x is approaching this slant asymptote y. We'll learn in a few minutes here what the equation for this asymptote is. Location of slant asymptotes. Suppose r is a rational function and r of x equals p of x over q of x, where the degree of p is exactly one more than the degree of q. Then the graph of y equals r of x has the slant asymptote y equals L of x, where L of x is the quotient obtained by dividing p of x by q of x. Let's look at an example. R of x equals x squared over x minus 2. The degree of the numerator is 2. The degree of the denominator is 1. The degree of the numerator is exactly 1 more than the degree of the denominator, so we have a slant asymptote. Should the degree of the numerator have been 3, say this was x cubed over x minus 2, we would not have a slant asymptote. To find the slant asymptote, I'll use long division here. I'll divide x squared by x minus 2. So x into x squared goes x times x minus 2 is x squared minus 2x. Subtracting, I get 2x. X goes into 2x 2 times. 2 times x minus 2 is 2x minus 4, giving us a remainder of 4. We ignore the remainder here. The slant asymptote is the quotient. And so here my slant asymptote will be y equals x plus 2. This is the slant asymptote of the graph that we looked at just a minute ago. Try on your own. Find the slant asymptote of the rational function h of x equals negative 3x squared plus 11x minus 11 over x minus 4.